right, welcome to the next session. Next up, we have the one, the only, the member of all the teams, Sledge, Steve McIntyre, talking about Secure Boot in Debian, in Buster, really. We look forward, Steve.
Oh, hey folks, how is everybody this afternoon? What an awesome time to get the first session straight after lunch on the first day. Hopefully, I'm not going to send people to sleep too much. So, Secure Boot. As I say on most of my sessions, this is a BOF. This is not just me talking. Please, if you have questions or comments, hopefully not rotten fruit, but we'll see, please shout up. I want this to be a discussion. If you have questions about anything of what we have, please say so. Usual things apply. Please grab a mic, because otherwise people on the video won't be able to hear you. But we want this to be an open session. This is, we're doing this in the open. I'm going to go through briefly, not in great technical detail, what UEFI Secure Boot is. I'm going to describe how it works in the Linux world and how it works in Debian. We have some not so good bits. We have some good bits I'm going to go through. There is a GOBI document. Sorry, microphone is mobile. There is a GOBI document as well. Please put some notes in there. Tomasz at the front has already volunteered to help. I will do my usual thing of posting a summary of the session to the Debian mailing lists at some point in the future when I get round to it. I like to share what we have. So, what is Secure Boot? Purely and simply, it is a way for the firmware of your computer to validate that the binaries it's running are the right ones and they are not infested with malware. The way that works is there is a chain of signatures which can be validated. I will go into more detail later on exactly how it works if people want, but fundamentally, who in this room doesn't understand how public key crypto works? Who in this room claims that they understand fully how public key crypto works? So this is not meant to be a way of locking down your system completely. The point of UEFI Secure Boot is to stop boot time malware. We've all heard of the problems in the past with boot sector viruses and that kind of thing. This is an attempt to solve that problem. If some software on your computer can modify your boot files or the boot sector, then of course it used to be the case that it could then basically take over your computer forever. If you can't trust all the way up from the firmware, you never know that even before you if you want a Windows system, if you start your virus checker, you don't know that you're in a clean state before you start. So that's where this came from. It is included on just about every modern x86 machine. It can also be disabled. You don't have to do all this. However, it is a genuinely useful technology and we should be part of it. So, in the Linux world, we have, as a community, all come together around one piece of software. Matthew Garrett started the Shim project years ago. It has a very, very simple job in life. It is a tiny, well-understood, well-reviewed piece of software that the Linux community work together on. It is then signed, and it then carries on the chain of trust to the next set of binaries. There's a reason for this, and I'll come to it in a moment. Main thing is, it is a collaborative project. Since I got into the EFI team in Debian and started working with EFI maintainers across the other distros, I've ended up getting into the team that reviews other people's patches too. As you can see, in theory, when Secure Boot started, Microsoft set themselves up as a CA, really not, so they could lock down a computer and stop Linux happening. They had a problem with boot sector viruses. They are entirely happy for other people to use the same technology. What eventually became clear over time was Microsoft have no idea how to review a Shim binary. They admitted it. So in the end, they came back to the team who were maintaining Shim to say, please tell us that this binary or that this source and binary that somebody has given us actually is a sensible Shim, and then we'll go and sign it. So I'm now part of the team that does that. So along with Peter Jones at Red Hat and Mathieu at Canonical and a bunch of other people, we're working together. This is good stuff. Shim literally embeds further keys and then loads more binaries. The binary that it wants to load is grub, because that's what everybody is using. The point of Shim is that we can get away from having to have, say, Microsoft signing grub. They don't want to sign grub because it's GPL3 and they don't like it, which is it's up to them. What they will do is sign Shim, and the Shim that Debian or Ubuntu or Fedora or whoever ship will have embedded keys that we know, that we trust. So, for example, in our Shim binary, we have a Debian root certificate, a Debian public key. You can also, using the mock, the machine owner key, embed your own signatures. You will, even if you want to use Secure Boot, you can literally turn off everything else in the system and just have the system support your keys. This is a really useful, powerful thing, and I'll come back to it later. So, our Shim contains a public key. We have signatures using that key on Grub and on Linux and on the firmware update tools. We could potentially sign other things directly if we need to. If you think that you have stuff that genuinely needs to be run and trusted here, talk to us, we can add you. We'll need convincing, of course, because anything that is signed here will have to have good security review for obvious reasons. If you do go through the Secure Boot route, if you have enabled Secure Boot on your system, then that will also, of course, give you restrictions on functionality to go with that security. You will not be able to run unsigned kernels. This has been a bone of contention in the past. Ubuntu shipped with a Shim that, with a grub that would run unsigned kernels, and it's not what the rest of the community agreed with. They've changed that policy since. The right answer is, if you have got Secure Boot enabled in your platform firmware, this is what you're signing up to. If you don't want this, turn off Secure Boot. It's an easy choice. There are other things that you get. You don't get to run, at the moment, non-free kernel modules. There are ways around this that would involve you signing those modules yourself on your system, and then using that signature via the machine owner key setup. You can then tell your system to trust those. This is not as well automated as it should be. It's something we will improve over time. One thing that does surprise people is you will not get hibernation here. There's a chicken and egg situation in that all of the state of your system is dumped into the hibernation file. Therefore, how do you secure that hibernation file with information that's not inside it? It's very difficult for a system coming up cold, to know that it can trust that. I'm sure that bright people will come up with better answers, but for now, if you have Secure Boot enabled, the kernel will say no when you ask to hibernate. There are more. There is documentation about this. I'm not going to bore you with all the details. But again, these are reasonable restrictions based around security. You can turn them off as well, but these are the defaults. So, is this supported in Debian? Yes. finally. Literally, as of this year, we have everything deployed such that it should all work. So, what does that mean? We have support for 3 Debian architectures. That is AMD 64, i386, and ARM 64. 99.999% of the systems that you're going to play with this are going to be AMD 64. But hey, we're Debian. We don't just do single architectures. i386, there are genuinely some systems out there that have it, although only a fairly small number, because of course new i386 systems are quite rare these days. ARM 64 has, for bigger systems, let's say the server boxes, absolutely can support Secure Boot, but until very, very recently, no one has actually sort of worked out how to do, or has volunteered to be the CA underpinning it. In the end, Microsoft has said they'll do this too. It hasn't propagated to many new machines. It will be coming soon. The packaging for the signed packages and everything in Debian are all done using recommend. Be aware of this. If you're one of the people, one of the control freaks who does not who always uses no install recommend with apt, you will not get this out of the box. That's fine, and there's a reason for this, is we understand not everybody wants these extra packages, not everybody agrees with them. We're not going to force you to have all of the signatures and all of the Secure Boot path set up, but it is there. You will get it by default on new installations. Again, you can remove them because it's not hard dependencies. The key thing is, obviously, we want this to work invisibly. If you notice that there's something wrong, modulo hibernation doesn't work or something, then we failed, of course. So we already have, with Buster, we have all of our DI images just work with Secure Boot. We have our live media, again, just working with Secure Boot, and they will both propagate to systems that are installed using those media. Cloud images, some of the cloud providers are very much wanting this because they clearly want to have security and trust on everything that's running. It's not yet totally pulled through. It will be shortly. So, how do we do this in Debian infrastructure? This has been the fun part. We had many, many variations on this, but here was where we got to. We have, for those packages where signing matters, we will have signed and unsigned versions of the packages. They may not always be labeled as such. For example, the Linux packages now, the binaries, do not mention that they're signed, but they are. But the packages that come from the unsigned Linux source will be labeled as unsigned. We have Shim and Shim signed. We have Grub and Grub signed, and so on. The way that we do this is really complicated on first acquaintance, but it does work and it is understandable, and we are reasonably happy it's secure. That's the whole point. Every source package that needs to generate signed binaries also ends up generating a set of template pseudo-source packages. Has anybody seen those turning up in the archive? Well, those of us involved, obviously, and a few other people. Again, this is all, it doesn't really matter exactly how it works for most people, but there is a path through the archive here. So as we upload our source packages and new binaries are built, we explicitly want to have reproducibility for everything that we're signing. Reproducibility is good, yes? And then, once we have the binary template packages in the archive, the next step of the process is that a signing service running alongside DAC, maintained by the FTP master team, picks up on those, recognizes that they do not yet have a signature attached, and will pick out those packages, pull them apart, while running no code whatsoever from those packages, because again, any code that could be run is a potential attack. Literally, it pulls metadata from those packages and nothing else. It will go and grab the binaries that have been built by the buildees and will apply a signature. All of the signature apparatus is as locked down as we can possibly manage. The keys themselves are stored in an HSM. So again, this is all following best practice. We genuinely do not want to see bad people get hold of Debian keys and masquerade their Trojan binaries as signed by Debian for Secure Boot. That would defeat the whole point. What this does mean is there are two build passes here, because of course what the signing service then does, it then pushes back a new source package which literally just contains the binaries and signatures that can then go back to a buildee to be put together and job done. If anybody wants to have a look at this, obviously all of the details are available. We have deliberately gone through and documented a lot of this. Transparency around what we're doing with security is a really, really important thing. So, the awkward bits. It's taken us a very, very long time to make this work. I remember standing on a stage 7 years ago at DebConf 12 in Nicaragua talking about Secure Boot. Why has it taken 7 years? The answer is, it's awkward. It has needed cross-team collaboration in Debian between people from at least 5 different teams. I'm sure I've missed somebody. Please point out anyone if you think I have missed anyone. None of this is blame. Believe me, I'm not trying to blame anyone here. Debian is great when we can scale with lots and lots of individual people who don't need to block on each other. That's how we managed to have 1,000 or so DDs all doing lots of work. If we all had to ask for approval from everybody else, we'd have died years ago. The difficult piece is when we have busy people from busy teams not quite syncing up. And we had several different possible designs on how to do this, which would go through and we think, oh yes, that might work. And then the person from the one team who couldn't have been there at the meeting or at a DebConf or reading email or whatever would point out actually a fatal flaw in our design. And going around that multiple times was a little bit demotivating, I think. I think it's fair to say. Eventually, where we got to last year, we had a sprint in Germany in April, and we got people from all of the right teams around the table together, and suddenly, big win. We got a design that worked. People could actually give good feedback on the design in minutes rather than weeks, and it's amazing how much difference that makes. And this is where we got to. It is genuinely amazing how much effort has gone into this, and thank you to everybody who's been involved. I will start naming names later. There are other awkward bits about this. Who likes OpenSSL? So OpenSSL is a good example of a security-related software, which is, in my opinion at least, and I've heard many matching opinions, it's terrible to use. It's very difficult until you're an expert in it. Actually understanding how you're meant to use it is hard. If you try to use it without that knowledge, you'll typically get it wrong, and you might actually end up not generating the security you're after, which is the whole point of using it in the first place. Now imagine the tooling around Secure Boot. Instead of the thousands or tens of thousands of users around the world who've been using this and knocking off the rough edges and getting the docs updated and filing bugs. Imagine that kind of software with about 50 and this is probably an overestimate, maybe 50 users worldwide, and you can imagine what we're talking about. I'm not trying to be nasty about the people who've written these tools. I understand exactly how this works. It's genuinely difficult to get good software without more people using it, more people buying in. We all understand free software. It works better when you collaborate and when you can share your ideas. What I found during the Buster cycle was I ended up being bitten by bugs in 2 different tool chains around this, PE sign and SB sign tool, that needed fixing before I could actually get on with getting our signed shim into Debian for the Buster release. That was slightly unfortunate. Of course, the other things that we have is because we have more firmware involved, we're going to find more firmware bugs. One of the more unfortunate things that we find with UEFI compared to old school BIOS boot is because there is more software involved, there is more scope for bugs. And until lots more people have been using this and found the bugs, we're going to carry on finding them. There's all kinds of obscure things. There are going to be similar problems with Secure Boot. I know there are, but all we can do is fix them as we find them. As I mentioned earlier, there is another problem with non-free drivers. If you want to genuinely run non-free drivers, the NVIDIA drivers are the most common things that people want. We do need to follow through. The Ubuntu folks have done some work in this place, which of course is good and free, and yes, we can steal it. We're going to. Sorry? It's mad. Yes, it's madness, but it's a way of fixing this. It's unfortunate. Obviously, none of us like running non-free software, I hope, at least in this audience. But if you genuinely have a machine that won't work without, it's not great if you then can't also get Secure Boot. So, we have some awkward bits. We also have some good bits of this. Wouldn't it be nice, and we're now seeing this, if an AMD 64 machine that you just bought out of the box will just install Debian? You no longer have to fight, or even worse, talk through your non-computer savvy relatives. You'll no longer have to explain to them how to go into the BIOS with all of its scary messages and turn off the security features. Because none of this is good. Now we don't have to. This is one of the main drivers for this. We have better support for secured systems. It's not complete end-to-end. If you really genuinely want to have a totally locked down system, however, this is part of that process. If you don't want a totally locked down system, of course, as I made great pains to say earlier, this is all optional. You can disable it. You can control this. User freedom really matters. As I said, you can genuinely go in on any system out there. It's part of the required spec. Modulo bugs happen, but it's part of the spec for Secure Boot that you can disable all of the keys that came with it and just put your own in. So at that point, you get to choose what programs your system is running straight from firmware. I think that's an awesome thing. Hopefully it works for you guys too. So, thank you to everybody. I am going to embarrass people. There are several people in the room who worked on this. So, stand up. Come on, stand up. Not everybody is here. And believe me, this is absolutely the point where I got to do the end bits of this and tie the last few bits together and push stuff through the archive. We had a lot of people, Tolef, Helen, Luke. We had Ben Hutchings, we had Ganef, we had Ansgar, we had Aurelia, we had, who else? We had people from the release team who were working through this with us as well. It is genuinely a multi-team effort. I'm standing at the stage here today to talk about this because I want to share that love with everybody. You know, it was a lot of work, don't get me wrong. And it's one of those, it was a lot of work, even when I thought, yay, it's just about done. It then took a lot more work. It's the final bit of polish that takes the effort. But genuinely, I am over the moon. This is a feature we've been trying to land for really more years than I care to think about. So hopefully it's a good feature everybody's happy with. So is there anything else people would like to talk about? Wow, I really have taken quite a bit more time than I thought with those slides. Talk to us. What would you like to know? What would you like to say? But obviously, with a microphone, please. Stunned silence. We have one.
It's not so much question as comment, and sorry, I'm not trying to take over this, but I try to play with it. I have this Purism laptop, so they don't use Secure Boot and UEFI, but they use Coreboot. So I try to play and some of my notices. Basically, Secure Boot, and UEFI, correct me if I'm wrong, the keys are embedded into kernel, so they are not in separate files, and they use special binary format. In this Coreboot and stuff, basically they put keys directly as separate files, so basically they SHA-256 or something, and then they sign this. So this is separate. I was hoping that it would be able to use the same key and then sign and then slightly change this Coreboot to do this. It was not working, and now
that's a shame.
Yeah, unfortunately. So it will require more effort.
Sure.
It's still the Coreboot from this Purism. It's still in beta, so they are not even installing by default. So you need to hack it a bit, and they are constantly changing. So
fine.
I'm not risking this installing here because I need to have working laptop.
Sure. So this is the first cut. We've delivered the common case. Let's be honest. So Dimitri was talking to me earlier as well about, so why don't we yet have secure signatures on PPC64 binaries and on S390X? The answer is just we haven't got there yet. One of the things that we wanted to do with the infrastructure for our secure boot setup was we knew we were planning ahead, is we wanted to make it feasible to also support other authentication and signature mechanisms. If you have other things that you think we should be doing as well, please talk to us. Obviously, patch is welcome. If we genuinely don't have those systems, it's difficult for us to play with them. So far, this is mostly x86. As I mentioned, ARM64 is a thing. Lots of bigger ARM64 systems are using EDK2, which is the reference implementation of UEFI, but not all of them. On the smaller systems, U-Boot is obviously much more common. The U-Boot folks have added EFI support and are genuinely working on Secure Boot as well. So much as you want your laptop and you want your server to be secured, potentially with your own keys or with platform keys, we can have exactly the same kind of type of technology securing all of your embedded devices too, and wouldn't that be awesome? Tolef.
Yeah, so the signing service actually is completely pluggable when it comes to the how it signs and how it does all of the verification of the binaries. So as long as you can get to a point where you can actually do it by hand, then it should be fairly simple to plug that into the machinery and build the template packages and do the same thing for Purism and S390X and everything, sure, as we're doing for Secure Boot.
Yeah, we also had questions at a previous DebConf and elsewhere about, so could we support all the roots of trust and not just say the Microsoft keys? And again, absolutely we can. I have worries at least about having multiple sets of signatures on the same binaries, but there was nothing stopping us, for example, having a different shim that is signed with a different platform key, and everything else rolls forward from there in just the same way. Yes, hi.
Concretely, if my laptop needs non-free drivers, for example, for Wi-Fi, Is it going to work now? And if not, what is the next step?
Sure. Do you actually need non-free drivers for Wi-Fi or just the firmware?
Drivers for Wi-Fi?
Okay. So again, at the moment, we don't have a complete solution for setting up your signatures. We can talk you through it, so you can sign your own non-free drivers and then make the system trust those just the same way. I said the NVIDIA drivers are the most common one. There will be some wireless drivers. It's something we're working on, so it should be much better automated. For now, you're better off disabling Secure Boot until we get there, or help us work out how to do it better.
Thank you.
Thanks for the work, Steve, and everybody else. One idea to make it better is that you would be allowing the system to have a local key that is later than the MOK. So just trusted by the kernel, and a list of things which are re-signed locally after upgrade.
Sure.
For example, I use DKMS a lot.
Yeah.
And it's, it's completely nicely automated. I'm not afraid of Ben pushing a new kernel because my system will basically recompile stuff and, it works like magic. And if you were just adding to this DKMS stuff that it would be signing what is a KO afterwards, it
Sure.
would just automate and click in place and work.
So again, the kernel has a key ring. It doesn't just take one key. It should be inheriting the key that comes out of Shim through mock or whatever. But yes, absolutely, you can also add more keys. We do need definitely to improve the process to make it easier for people.
The point was, don't do it at the UEFI level, do it at the kernel level. Have a trusted file which is 0600 owned by root. And if this is there, then sign it. Because it's still the user choice whether they want it.
Of course, the downside then is it is a security risk, of course, having anything that is kept on the system, because it does mean that anything that then gets root can then have persistent root across the next reboot by having a new signed binary driver.
Yes, but
it's a trade-off. It's a call you have to make.
There's no security risk, because the thing is, if you have root on my box, you can put stuff into my bash RC and be persistent as well.
Well, you can later. The point is, this is going to happen potentially right from system boot before you get in. It is a genuine concern. I understand. I know where you're coming from. It's something that that needs to be discussed, and people have to understand. They can then make that decision for themselves.
How does it work with EGPF and like system tab K probes with signed images? So basically, if you load a GIT image into a signed kernel, like does it alter anything about having its certificate, or because system tab's going to create the modules and EGPF is going to load the image?
There is a complete set of lockdown patches around Secure Boot that disable a lot of that kind of functionality just because of course, basically, if you can genuinely go and fob bits of kernel memory directly, whether modifying module behavior or doing all kinds of stuff,
you're losing it, right? Yeah.
Exactly. Then at that point, it's just you cannot do this while having security. It's a hard problem.
Okay, thank you.
And it's still an ongoing thing that people are adding more stuff to lockdown as I think about it.
Yeah, because you would have to have like the image itself signed to be loaded in the signed and so on. Yeah.
For example, I mentioned hibernation. I mentioned the non-free drivers. Automatically moving on to kexec to going on to another kernel is also problematic with Secure Boot. It's not impossible, but there are problems that you have to think about.
So, Steve, one more question to ARM64.
Yes.
We have a lot of small computers, mini computers in the world. So I have some problems to understand where's the line between the ATF and some secure stuff signed by the kernel or something. Can you please explain a little bit how the situation is exactly there?
Sure. It's still being defined right now. Is the easiest thing I can say. There is work going on from a lot of groups. I said the U-Boot people and the boot architecture people for lots of things. So all the way up from your embedded IoT devices up to servers to try and give a good, consistent view here. ATF, for those people who don't know, is ARM trusted firmware, which is the most common low-level firmware piece that people will end up encountering on a lot of ARM and ARM64 devices. It is often embedded into U-Boot or into EDK2 or whatever as part of the platform setup for each device. You will end up with a build of your firmware that will include keys. The most common way that that's going to happen is they will be built in by your system vendor. They're going to be no different to an x86. You will have a builder of firmware that comes with your device, and that will include public keys. It will then be able to verify things from there onwards. The exact mechanisms are still being worked out. People are talking about how do you verify things like device tree blobs as well, because obviously those have a great bearing on this. If you can modify the DT, you can basically tell this driver, go and scribble over that bit of memory, and then you've got whatever access you need. It's an ongoing discussion. I appreciate that might sound wishy-washy, but that's genuinely where we are today.
So you mentioned several times that users will have the freedom to run their own signed things,
sure.
Right? So if I'm rebuilding the kernel,
yeah,
can you describe the process of getting this kernel to be trusted
sure.
by
So
Coreboot?
there are a couple of ways you can do this. Genuinely, you can go and build your own binary kernel, and you can go and sign it all. You can embed a key with the kernel, it's part of the kernel config, and do everything that way. The other way you can do it is basically, you can copy what we've done in Debian. If you set up an equivalent signing service, and we have made sure everything we've done is free and documented and open, for exactly these reasons, you could actually set up your own completely separate but parallel signing infrastructure to basically do what we've done. You would then need to have either your own Shim, or you would need to have to embed your own keys in the mock database in Shim, or directly in the PK or KEK on your in your firmware, if that helps. I can explain those more. I don't want to go into great gory detail about the exact key setup, but if you can get to that level, and particularly if you have good access to low level, you can blacklist, you can remove the existing platform keys and have everything you own.
Or when you rebuild packages, you'll get the unsigned ones, then you manually sign them, and then install that key on the system, and you're good to go. Because when you rebuild the packages, by default, you will get the unsigned ones.
Yes.
And then you can just use normal kernel signing command lines to sign it with a key that you control on a controlled system, such that you don't have to automate it with the whole signing service.
Yes.
Or you could if you wanted to.
Yes. There's multiple ways. We've set up the signing service because we get bored of doing manual things very fast, let's be honest. And the downside for the way that we do things with Debian, for example, for the DI kernels, is we have lots and lots and lots and lots of little separate module packages. You end up having to basically sign every module independently. That takes a lot of effort. It takes a lot of time, hence why we really want automation. Yes?
So you said that the documentation and the materials are all there for someone to set up their own signing service.
Sure.
As far as you know, has anyone tried that yet?
I genuinely don't know, I'm afraid. We made a point of making all the stuff available. And when I say it's documented, it's probably not very good, because no one's really spoken to us about it yet, and so it's difficult to tell. But all the pieces that we've done are entirely open. Please go and have a look and shout at us if it doesn't work.
Is that it?
I think that's it. I hope that was useful for everyone. I am around. Talk to us on the Debian EFI mailing list or in IRC or whatever. We genuinely are interested. If you have a problem and you think that Secure Boot is not working for you on your system, please tell us, because again, the only way we will ever be able to fix bugs is if we're told about them, and we genuinely do want this to work for people. This is not just, we're not wasting our time here. But I hope that was interesting, and thank you for coming along.
Thank you, Steve, and the whole team.